All right, mass percent and empirical molecular formulas. So we looked at mass percent of an element in a compound in the first lecture. So a component could be a compound or an element in a substance or mixture. So you're not given this formula on the AP exam, so you need to know it. It's basically just like finding the percent of anything, the mass of that component that you're looking for over the total mass. So if we want to find the percent mass of iron, you'd find there's one iron weighs that, divided by your total, times 100, 36.81%. Mass of titanium, same thing, one titanium weighs that, over the total, times 100, gives you your percentage. Oxygen, we've got 3 oxygen atoms, times weight of 1 oxygen atom, divided by the total, gives you this. And when you check them, they should all add up to 100. A tablet contains 0.025 milligrams of vitamin D. The entire tablet, however, has a mass of 0.115 grams. Calculate the mass percent of vitamin D in the tablet. So mass of compound divided by the total mass of the substance, and you get 0.022% vitamin D. A sample of potassium permanganate is known to contain some impurities. It is found that the potassium ion makes up 19.24% of the entire mass of the sample. All of the potassium ions come from the KMO4 compound. Find the mass percent of potassium permanganate in the sample. So to work out this type of problem, we need to set up a ratio and cross-multiply. The ratio of the molar mass of potassium permanganate to the molar mass of the potassium ions is equal to the ratio of the mass percent of potassium permanganate to the mass of the potassium ions. So once you set up this ratio here, then you just solve for the percentage, 77.77%. All right, molecular and empirical formulas. Molecular formulas are chemical formulas that provide the actual number of each type of atom in a molecule. The empirical formulas, this is the reduced version. It's reduced to the simplest form. So hydrogen peroxide, H2O2, its empirical formula, HO, we've reduced it. Ethylene, C2H4, in its reduced form, CH2. Dextrose, when you reduce it, CH2O. Okay, so what is the empirical formula for water? They're the same because you can't simplify it. And this is often the case. Acetylene, C2H2, you just simplify it, CH. Hydrazine and 2H4, just reduce it like a fraction. A sample of caffeine was found to contain 49.5% carbon, 28.9% nitrogen, and 16.5% oxygen, 5.1% hydrogen by mass. Find the empirical formula for caffeine. So you're going to assume that you have 100 grams of a sample. This allows us to make a direct conversion from percent to grams. And then we convert each one of those to moles. Then you're going to divide the number of moles of each element by the smallest value for moles calculated from the previous step. So these whole numbers are going to become the subscripts for the corresponding element in the empirical formula. Okay. In reality, there are 2 hydrogen atoms and 2 oxygen atoms in hydrogen peroxide. So that would be the molecular formula, not just HO, the reduced version. The molar mass of caffeine is 194.2 grams per mole. Find the molecular formula for caffeine. Okay, by dividing the molar mass by the empirical formula mass, you'll get a whole number. Then you multiply all of the empirical formula subscripts by this number to get the molecular formula. You can find the percent composition and empirical formula of an organic compound made up of carbon, hydrogen, and oxygen by doing a combustion analysis. So all the hydrogen bonds to oxygen to form water, which is deposited in the water absorber. Then all of the carbon bonds with oxygen to form CO2, which is deposited in the carbon dioxide absorber. The increase in mass of both the water absorber and the carbon dioxide absorber is then found. This will allow you to determine how much water and carbon dioxide you have gained. Oxygen is the only element that is added to the system during the combustion reaction, as combustion takes place in excess oxygen, right? Okay, a 2.04 gram sample containing CH&O underwent combustion analysis. 4.49 grams of carbon dioxide and 2.45 grams of water were produced. Find the empirical formula. All right, so this is your thinking. You're going to use stoic to find the grams of carbon and hydrogen, subtract the total mass from the sum of the masses of carbon and hydrogen to find the mass of oxygen. Then you find the moles, and then you find the empirical formula. Okay, this time we're not going to assume that we started with 100 grams because we don't have mass percent values. So we have to use what they gave us in the problem. So find the mass of carbon and the mass of hydrogen first. Oxygen is the only other element in the compound, so you find that by subtracting the masses of carbon and hydrogen from the total mass. This is the only way that you can find the mass of oxygen in the compound, as oxygen gas was the excess reactant in the chemical reaction. So the mass of the oxygen in the CO2 and water would include the oxygen in the original compound and the gaseous oxygen in the combustion chamber. All right, and then we're going to find the moles, and now we're back to like how we do it regularly. And then we're going to divide by the smallest. All right, so try these for homework, and we'll check them in class.